What's up, guys? I'm in this room in McGill University. Sorry to location drop. Yeah, I'm in this room. It's very quiet. It's very nice because I don't want to be recording in like my dorm and stuff because people will walk by and after my fifth take of trying to say this hard sentence to pronounce, people are gonna think I'm a tweaker for just doing that shit. But we're talking about the arm. So I've been really busy with school, so I haven't done that much for the arm, I gotta say, to be honest. But I didn't do nothing. Okay, look, let me tell you, I got a commitment, I got a duty to finish this arm, even if it takes my entire 5-year degree. And that's okay, it's fine if it takes long, that's fine. And if you don't know what I mean by the robot arm, Loki, that's kind of on you. This is part 4. Like, get with the times, man. Just watch part 1, okay? And then 2, and then 3, and then you can watch this one too. And then you can like all 4 videos and comment and subscribe on 5 different accounts. That'd be amazing. So what's been going on? Last time where we left off, I designed a really basic model of the gripper because robot arms have to grab stuff. And in between then and now, I found a way to make them 3D printed. I started by taking the supports off the 3D printed parts that I made last time, like I kind of just said. Then I tried for like a minute to assemble them and realized, like, what am I doing? Like, what am I doing? Just like in general, because why am I starting with the hardest part of the robot arm before anything else? It's like eating dessert first. Like, designing this gripper first was such a bad idea because it's like trying to build a skyscraper by like starting from the 30th floor. That makes no sense and it's stupid because it's dependent on the dimensions of every single other part. And also, I made a lot of mistakes in the design and it didn't work, but that's just beside the point. So I put the gripper designing on hold and started from the beginning. I got a pencil and paper, like the old days, and I drew what the base of the arm is going to look like. This took a long time because it has special features. Like, it's not just a hollow cone. It's a hollow cone that has slots for tabs and whatever attachments you want to put in it. It even has one dovetail adapter if I want to like expand the base with some other gizmo or something, you know? But by far the thing that took the most time was a part, like an attachment with tabs, that's going to snap into the base piece and act as a crib for the first servo motor. So that doesn't make any sense, what I just said. It makes sense for me, but probably not for anyone who's watching this, right? It's just gonna be, okay, look, you know how like arm is like, you got the shoulder, like the bicep, the forearm, and the wrist and the hand. That's how an arm is built, I think, right? So I'm starting, the shoulder is kind of like the base, right? And like you can kind of rotate it a little bit, right? So around like one axis of motion. So there's gonna be the base and then motor on top. It's gonna like spin. And it's gonna spin the section that's gonna go on top of the base. So there has to be a way for the base to hold the motor so that the motor actually has something to push against. Does that make sense? Look, I made a drawing and I think the drawings turned out really nice and it makes a lot of sense if you look at those. And it's great. And you know, the reason why I did this sort of tab thing to begin with and not just put it all in one piece is that if I have to if I make a mistake in the crib design, I don't have to print out a whole base again. I can just print out that small piece with the tabs again. And that's so I can save a lot of material and it'll go faster and just more efficient. It's cool, you know? And I'm just kind of low-key proud to say that I lined up where the motor top is going to be exactly flush with the top of the base. So that's pretty cool. Anyways, to test out all these new joint types I'm using, like tabs and stuff, I made some small test pieces to see if everything is going to fit together. And that's about it for this month because I am actually struggling to find a 3D printer that I can use. After going through an actual drought in the summer where I couldn't really print anything, because you know, I don't have a 3D printer. I wish I did, but I don't. If someone wants to buy me one, that'd be great. I thought that coming here, there'll be like, oh yeah, for sure, there'll be tons of printers available. I even looked it up. There are some in this library, in this building, where I am right now. But the program was discontinued. They didn't say that on the website, by the way. You got to email the people to find out it was discontinued. And it's only restarting in October, which is like 3 years away, it feels like. I swear, if I had a 3D printer, I would be done with a whole arm by now. I'm just saying. Limited by the technology of my time type shit. On another note, A robot arm is unfortunately not just made out of 3D printed plastic. It has motors and electrical boards and circuits and wires and probably a lot of other things too. And those things cost money. And being in university, I have no money. But what I do have is 300 Monster Energy drink cans that I'm paid to give out. So I think we can make something work. And that's about it. Um, I'll post some other stuff in between next video, but it might be a bit of time. I gotta say, it might be a bit of time before I post the next video, because midterms are coming up, and I'm really bad at physics. I didn't know I was bad at physics until I got here. And that's when I found out that I'm pretty bad at physics. So, until next time.